Professor Belfrost's science class is back.
Hi, welcome back with me, Professor Belfrost, in my science class, and today we are going to discuss yeah the we are going to discuss mathematics. What I have left with you on my last lesson of mathematics is algebra, right? And this is the second lesson. This is the second lecture on algebra. Okay, we haven't done with algebra yet, and maybe there are three episodes dedicated for algebra. Okay, maybe this is the second, and the next video will be the last video about algebra. Okay, so let's review our first lesson on algebra. So there are some sets of numbers known in mathematics. This is very important concept, so I want you to pay attention to it. So numbers used for counting or enumerating items like 1, 2, 3, and so on are natural numbers or counting numbers. Second, the set of natural numbers plus 0, so 0, 1, 2, 3, and so on, so on. It is called, this set is called whole number set, okay? So whole number plus the opposite of the natural number is called set of integers, yeah? And rational numbers are fractions or quotients containing integers in both numeral and denominator, and the denominator must never be zero, because if you have the denominator is zero, then it means that you will make the operation to be undefined. Okay. Next point is that numbers that cannot be written as fraction of two integers is called a rational number. Yeah, like square root of 11, then 0.3003333003330, something that has irregular pattern. Okay, so they are not rational, not repeating, and non-terminating. Okay, next point is sets of rational and irrational numbers together make up the set of real numbers. Okay, so we actually have real numbers, that is rational and irrational number. We also have imaginary numbers. Okay, and actually the real numbers and imaginary numbers will later build a new set which is called complex numbers. Okay, maybe I not stated in this preliminary study, but maybe this concept will be useful after we have some more further discussion about mathematics. Okay, let's move on. Okay, so the distance between 0 and any numbers on the number line is called the absolute value of that number. Okay, there's the notation. Uh, yeah, so we can visualize numbers on number line where the point labeled 0 called the origin. Points are equally spaced to the right of 0 and labeled with counting numbers. Pair of number and point is called coordinate of the point. Okay. So a negative number is a number that is less than 0 and is actually just the opposite of the positive number. You can see the number line. This is very clear depiction, but maybe this number line is not complete enough because I didn't include negative numbers here. But here is just the number line. You can see that the point are equally spaced. Okay. Okay, so next we are now entering the realm of fraction. Okay, so a mixed number. What is a mixed number? Mixed numbers number consists of a whole number and a fraction. So it consists of a whole number, say a, and a fraction, say that the form is b by c. Okay, b over c, where c is not zero and it's written as follows. Okay, a and b over c. Okay. Now improper fraction. So actually there are two fraction. There are two kind of fraction. There are improper and proper fraction. So improper fraction is a fraction with numerator greater than or equal to the denominator. So its value is greater than or equals 1. But when a fraction has a numerator that's smaller than the denominator, then it is called a proper fraction, and its value is less than 1. And also for our last lesson, there are 5 properties of real numbers: commutative, associative, distributive, identity, and inverse property of a real number. So I want you to review the last lesson again, because the table of the properties of real number I didn't show you in this lecture, but we'll use these identities often to solve the algebraic expressions. So I want you to revise from the last lesson, okay, before going through this video. This is very important. Okay, so let's start our discussion today. So today we'll start an in-depth lesson about evaluating algebraic expression. So yeah, in algebra, there are two important terms. Okay, one is variable, and the second is constant. Maybe this term you have used quite often, so maybe this is not a very hard concept for you to grasp. Okay, so first variable, as the name states, so a variable is just anything, or in mathematics there is a letter, so a letter that represents a number or quantity whose value may change, while a constant is just a number whose value always stays the same. This is a simple example where you can see the difference between variable and constant. So there are two kids called Bertha and Tom. So Bertha and Tom actually have the same birthday, but they were born in different years. This year, Bertha is 10 years old and Tom is 12. So Tom is 2 years older than Bertha. But when Bertha reaches 13 later, okay, 3 years later, okay, Tom will be 15. No matter what Bertha's age is, Tom's age will always be 2 years more, right? Okay. In the language of algebra, we say that Bertha's age and Tom's age are variable, and the difference, which is 2, is a constant. The age changes and vary, so age is a variable. The years between them always stays the same, so the age difference is the constant. Okay, so I've done explaining you about variable and constant. I think that is the most important one. Okay. And we use these two terminologies in any algebraic expression. So what is an algebraic expression? Algebraic expression is actually just a collection of constants and variables joined together by the algebraic operations like addition, subtraction, multiplication, and division. Okay. So when exponent is used with variables or constants, this exponent tells how many factors of the base to use, whether the base consists of constants or variables. So I have taught you before about what is an exponent, and I want you to revise it again from the last lecture. Okay, so any variable in an algebra expression may take on or be assigned different values. When that happens, the value of the algebra expression changes. To evaluate an algebraic expression means to determine the value of the expression for a given value of each variable in the expression. So you just need to simply replace each variable in the expression with the given value, then simplify the resulting expression using the order of equation. Okay, order of equation, PEMDAS. I want you to memorize that. Okay, quick example. So list the constant and variables for this algebra expression. Okay, so we have 8/9 times pi times square root of 2 times x to the 5 times y to the 3. So the answer is very simple. The constant is just any numbers, any numerals, which is not letter. So we have 8/9, and we have pi, we have 2, while the variable are x and y. Okay, so it's very simple. Another quick example, evaluate the expression for the given value, which is square root of 2 times m to the 3 times n to the 2. Okay, for m equals 2 and n equals 3. So the answer is that you need to substitute every m term that you find to be 2 and n with 3. Okay, just plug in just substitute the value and you will have 12 with you. Very simple. This is just elementary school problem. Okay, now we're moving to another term, which is equation. So an equation in algebra is a mathematical statement indicating two expressions are equal. So the expression can be numerical or algebraic. Okay, no matter which one. The equation is not inherently true or false. So we cannot say that this equation is true or false, but we need to know which value it used to solve this equation, to know the truth value of the equation. Because an equation is just basically just a proposition. Okay, the values is what makes an equation true or false. Okay, and the true value and the values that can make an equation true is called the solutions to that equation. For example, say that an equation has a solution of 3 because when we substitute 3 for this equation, we obtain the true state. Okay, say for example, x minus 2 equals 1. Okay, when we substitute 3, then this we make this expression to be true. So 3 is the solution to this equation. Okay, now a formula. What's a formula? A formula is just actually basically a equation, the same equation, expressing a relationship between constant and variable quantities. Okay, very often the formula is a means of finding the value of one quantity of a single variable in terms of another or other quantities. Okay? One of the most common examples that maybe you use most, okay, is say this is the easiest one. The formula for finding the area of a circle in terms of the radius of the circle. A equals, yeah, pi times r squared. Yeah, very easy, right? This is just a quick example. Given that a right circular cylinder with radius r and height h has the surface area s in square units, and you are given the formula of s equals 2 times pi times r times the summation of r and h. So find the surface area of a cylinder with radius 3 inches and height of 4 inches. Leave the answer in terms of pi. Okay. So the answer is quite simple. Just need to substitute the r with 3 and h with 4, right? So it's very easy. 2 times pi times 3 times sum of 3 plus 5. 3 plus 4, I mean. This is 2 times pi times 3 times 7. So we have 42 pi square inch. Okay, very simple. This is just elementary subjects. Okay, but you need a strong concept of this to move to the next chapter of mathematics, right? So to simplify algebraic expression, we just need to use properties of real numbers that have been taught before, right? Quick example: simplify the algebraic expression of 4t minus in parentheses 4t minus 5 quarter s minus in parentheses 2/3 t plus 2s. So the answer is just you need to first using the distributive property of a real number. So we have 4t minus 4 quarters s minus 2/3 of t minus 2s. And next, you need to apply commutative property of addition. Then we have 4t minus 2/3 of t minus 5/4 of s minus 2s. Then we can just simplify the expression by doing the simple operation, arithmetical operation, and we can obtain 10/3 of t minus 13/4 of s. Next, we'll discuss about product rule of exponents. So we starting from, and now we have start the first rule of exponents, which is product rule of exponents. Okay. So say that if we have two exponents with us, a to the m and a to the n, see the base is the same, a, okay? And we want to multiply this expression. How can we do it? We can use this rule. A to the m times a to the n is actually equal to a to the n plus n. Very simple, right? For example, y to the 2 times y to the 5 times y to the minus 3. Then we have y to the, okay, sum of 2, 5, and minus 3. So basically just live with y to the 4. Very simple. The second rule, this is the quotient rule of exponents. So this rule allows us to simplify an expression that divides two numbers with the same base but of different exponents. The rule is a to the m divided by a to the n equals a to the m minus n. Very simple. For example, say you have the basis z times square root of 2. Okay, so z times square root of 2 to the 3 divided by z times square root of 2 square. So because the base is same expression, z times square root of 2, then we can apply the second rule, right? So in parentheses, z times square root of 2 to the power of 3 minus 2. So because the power is just 1, we don't need to write it, okay? So we can just express it as z times square root of 2. Very simple. And then the third rule, let's move to the third rule. So the third rule is the power rule of exponents. So when raising an exponential expression to a power, we write the result with the common base and the product of the exponents. That is, if we have the expression of a to the m, then we power it again with n. Okay, so a to the power of m to the power of n. So actually, we can simplify this as a to the power of n times n. Quick example, we have 3a to the power of 7, then this expression to the power of 10 again. So we can just simplify it as 3a times 3a to the power of 7 times 10. So 3a to the power of 7. Very easy. The fourth rule, we have 6 rules in total, okay? So this is the fourth one. The fourth rule is the zero exponent rule of exponents. So the rule is that a to the 0 equals 1. Always a to the 0 equals 1. A can be constant, can be expression, it can be variable, can be expression, and this always results 1. Quick example. So say that we have the expression like this on the slide. I want to read this long expression for you. Okay, pay attention by yourself. So by using the product rule in the denominator, we can have this simplified expression also shown in the slide. Okay, and you see that it can be further simplified as this expression. And because we can apply the quotient rule, now we're left with j to the 2 times k to the 4 minus 4. Because 4 minus 4 actually equals 0, so this expression to the 0 is actually just 1. So this is very simple, right? The fifth rule now. So the fifth rule is the negative rule of exponents. So it states that a factor with a negative exponent becomes the same factor with a positive exponent if it is moved across the fraction bar from numerator to denominator or vice versa, or expressed as a to the minus n equals 1 over a to the n, and a to the n equals 1 over a to the minus n. So quick example for you. So we have minus 5t squared cubed over minus 5t squared to the fifth power. So we can just simplify it as minus 5t squared to the power of 3 minus 5, and 3 minus 5 is actually just minus 2. So minus 5t squared to the power of, together this expression, to the power of minus 2. So this can be made as the using the negative rule of exponents, can be made as 1 over in parentheses or in bracket minus 5t squared again. Okay, we just make it into the reciprocal form. Okay, so the sixth rule is the power of a product rule of exponents, so which brings up the power of a product of factors into the product of the powers of the factors. It can be expressed as a times b together to the n equals, you just split it, a to the n times b to the n. Quick example for you. Say that we have expression a to the minus 2 times b to the 2. Okay, I mean a to the minus 2 times b squared. And to get the expression to the power is raised to the power of 7. Then we can just split this. So a to the minus 2 to the, we can raise it to the power of 7, and then times b squared raised to the power of 7. So we can just basically do the previous rule. Okay, so a to the minus 2 times 7 times b to the 2 times 7. So we are left with a to the minus 14 times b to the 14. Or to make them all have the positive exponent, so we make it as b to the 14 over a to the 14. Very simple. Oh, actually there are more than 6 rows. I forget it. I'm sorry. So now it's the seventh rule, which is the power of quotient rule of exponents, which states that the power of a quotient of factors is the quotient of powers of the factors expressed with the formula a over b to the n equals a to the n over b to the n. So I want you to pay attention to this sentence. The power of a quotient of factors is the quotient of the powers of the factors. Power of a quotient of factor is the quotient of the powers of the factors. So the first one is that you have an expression contains quotient or fraction. Then you split this fraction to be numerator and denominator, which every numerator and denominator carry the same exponent. That's the meaning of this sentence. Actually, this sentence is quite confusing. Okay, so just quick example for you. So we have the expression 4 over z to the 11th, and this is raised to the power of 3. Then we can just apply like a distributive property actually. we can just apply the exponent to every term of numerator and denominator. So we have 4 cube over z to the power of 11 raised to the cube raised, yeah, I mean cube again. Okay, then this is equal to 64 over z to the 11 times 3. So we left with 64 over z to the 33. Very simple. Okay, so we have done with the concept of the rules of exponential things. Okay, we have done with that. Now let's move to another uh, topic, which is scientific notation. Okay, so scientific notation is actually a very important concept for writing very small and very large numbers. And I have covered in this in physics lecture. And I want you to pay attention to that lesson on physics, units, and measurements. Okay, because I cover this section, I covered this topic in my last physics lecture very deeply, and I also cover how to do operation using significant figures, while in the mathematics, because I use different books and they doesn't cover significant figures, and maybe you'll miss that part, and I will not cover it again this time because it will waste my time. Okay, so yeah, so what is the purpose for you to write something scientific notation? Because you make your expression a number, your constant to be more comfortable to be read. Okay, so how to write the number in scientific notation? So you just need to move the decimal point to the right of the first digit in the number. Write the digits as a decimal number between 1 and 10. Count the number of places n that you move the decimal point and multiply the decimal number, I mean, by 10 raised to the power of n. The rule is that if you move the decimal left as in a very large number, it is positive. But if you move the decimal right as in a small large number, okay, I mean a very small number, it is negative. And the scientific notation is expressed as a times 10 to the n. A quick example for you. The diameter of an electron is this 0.000 blah 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 94 meters, and this can be expressed as 9.4 times 10 to the minus 30 meters, because you can pay attention to how much we need to move to reach the first non-zero digit, which is 9. We move 30 position to the right, so we need to subtract 30 position back. Okay, whereas the distance of Earth to Andromeda galaxy is this 24 with 1, 2, 3, 4, 5, 6, 7, 7 pair of 1,000 meters, and this can be expressed as 2.4 times 10 to the 22 meters. Very simple. So the last lesson for today is about radicals and rational exponents. Okay, so the principal square root of a is the non-negative number that when multiplied by itself equals a. So it is written as radical expression with a symbol called a radical over the term called the radicand, which is square root of a. If you are now applying square root, okay? A principal square root as a result of the radical symbol implying only a non-negative root must never result in negative number. Though maybe both of the result are valid, but for a principal square root, this is a positive number. Now let's discuss the product rule to simplify square roots. It states that if a and b are non-negative, the square root of the product ab is equal to the product of the square roots of a and b, which is square root of ab equals square root of a times square root of b. The quick example is like this. So we have this expression, and we just need to factor the perfect square for the radicand, and then write the radical expression as product of radical expressions. And we obtain this 9 times a squared times b squared times square root of 2a. The last rule about the quotient rule to simplify square roots. So for any square root of quotient a over b, it is equal to the quotient of the square root of a and b, where b is not 0. So if we have the form of square root of a over b, then it is the same as square root of a divided by square root of b. A quick example for you, let's simplify the radical expression that's shown in the slide. So the first step we need to take is to combine the numerator and denominator into one radical expression, okay, like the expression on the slide, okay. Then let's simplify the fraction. So 234 divided by 26, it is 9, and x to the power of 11 divided by x to the 7, that is x to the 4. Y and y, we have no left, okay. So the simplified fraction, the simplified expression, I mean, is the square root of 9 times x to the 4. Then let's simplify or do the simplification further, and we have square root of 9 is 3 and square root of x to the 4 is x squared. Okay, so that's the answer. For adding and subtracting square roots in a radical expression, so first we need to simplify its radical expression, and second, add or subtract expression with equal radicands. Okay, I'll give the example in let's practice section. Last for today, to rationalize the denominator, we need to follow these simple steps. If you're given an expression with a single square root radical term in the denominator, then we must first multiply the numerator and denominator by the radical in the denominator. Then we can further simplify it. For example, this very simple example, let's say that we have the expression 12 times square root of 3 divided by 3 times square root of 10. So because we have square root of 10 at the denominator, and that is the radical that we can use to simplify this. So we just need to multiply both the numerator and denominator by the sum of square root of 10. Okay, so we have the expression that's shown in this slide. Then we obtain 2 times square root of 13 divided by 3 times 10, right? Okay, or 13. So we can simplify it further. So we have 1/5 times square root of 13. If we are given an expression with a radical term and a constant in the denominator, it means it's an expression, not a single constant. So what we can do, the first is to find the conjugate of the denominator, then multiply the numerator and denominator by this conjugate. Use the distributive property, and then you just need to simplify the expression. What is conjugate? Conjugate is just the denominator with the sign being changed. Okay, let's see if I can show you what conjugate actually is. So for quick example, write down 5 over 1 plus square root of 5 in simplest form. So here the denominator is 1 plus square root of 5. This is the expression of the denominator. And what's the conjugate of this expression? This conjugate is just the sign being changed. So before we have 1 plus square root of 5, it means that now the conjugate of this denominator is 1 minus square root of 5. Very easy. And we have the expression as shown in the slide. Then by using distributive property, we just obtain new equation, which is 5 minus 5 square root of 5 divided by 1 minus 5. Okay, so we have 5 minus 5 square root of 5 divided by minus 4 or negative 4. Then just simplify it, then we obtain 5 quarter times square root of 5 minus 5 quarter. Actually can make it in mixed number, I don't mind, but I just show you the fraction form. Okay, so although square roots are the most common rational roots, we cannot just uh, just say that we only want to perform any operations that in square roots. We can also find some like cube roots, fourth roots, fifth roots, and more. Just as the square root function is the inverse of the squaring function, so actually these roots are the inverse of the respective power functions. So the nth root of a is a number that when raised to the nth power given a. Okay, for example, minus 3 is the fifth root of minus 243 because minus 3 to the power 5 given minus 2 gives us minus 2, 4, 3. If a is a real number with at least one nth root, then the principal nth root of a is the number with the same sign as that when raised to the nth power equals a. The principal nth root of a is written as the equation that is shown in the slide, where n is a positive integer greater than or equal to 2. In the radical expression, n is called the index of the radical, yeah, while a is the base, okay? So, quick example, we have the expression as shown in the slide. You are about to simplify it. So, how can we do this? So, first we need to write it as a quotient of two radical expressions. So, we have minus cube root of 8 times x to the 6 divided by cube root of 125, and then we can simplify it as minus 2 times x squared divided by 5. Very easy. Okay, and radical expression can also be written without using the radical symbol. We can use rational or fractional exponents. The index must be a positive integer. If the index n is even, then a cannot be negative. It is expressed as a to the power of 1 over n equals to the square root of a, the nth root of a, I mean. Yeah. We can also have rational exponents with numerators other than 1. In these cases, the exponents must be a fraction in lowest terms. We raise the base to a power and take an nth root. This numerator tells us the power and the denominator tells us the root. It is expressed as a to the power of m over n. That's equals to, yeah, the expression is shown in the slide. So for example, a quick example for you is that, for example, we have to write the expression of 343 to the power of 2 thirds as a radical and we need to simplify it. And here's the answer for you. The 2 here tells us the power and the 3 tells us the root. So we can create the expression as shown in the slide. But we know that the cube root of 343 equals 7 because 7 to the power 7 cube equals 343. Because the cube root is easy to find, it is easiest to find the cube root before squaring for this problem. So in general, it is easier to find the root first and then raise it to a power. So we can just take the cube root of 34337 and then we square it and we find the answer, which is 49. That's done. Now let's practice some. Okay, first is simplify expression and write the answer with positive exponents only. A, B, and C. Okay, so I want you to take a screenshot and I want you to review it by yourself because I want to explain one by one because there are many rules that you need to review it back. Okay, you just pause this video and go back to the timestamp that I've given to see if you have understood the concept or not. Okay, so this is the first. This is still the first, but this is the solution for C. Okay, and this is for the scientific notation. This is the second. Okay, this is the solution, and this is the third. This is the last one. To for the expression that have radicals. Okay. Okay, very simple. So yeah, that's the lesson for today. I'll not give you any assignment for today. Okay, here is a little inspiration for you today. So Buddha once said, your time is limited. Don't waste it living someone else's life. The mind is everything. What you think, you become. Okay, so thanks for watching and please subscribe and give a like. Share it to your friend. And there's some change in the schedule of my class. So my class starting from today will only be on Tuesday and Thursday every week as there is increasing busyness in my teaching schedule. So keep watching and be thoughtful. Thank you. Goodbye. See you all.